Hello and welcome to today's lesson. We're going to deal with our right triangle unit 4, lesson 1. And today we're going to investigate the law of sines and then also be able to find the area of any triangle given that it's a side angle side triangle. So now, if we look at this triangle that we have here, we can notice that we don't have all the information to be able to find the area of this triangle. We know that the area of a triangle is 1/2 length of the base times the height. Okay, we're close. We've got the base length of this triangle, 33. Okay, what we do not have is the height of the triangle. So in this case, we can find the height of the triangle using our right triangle trig functions. So we want to find the height given the hypotenuse. Okay, we don't want to use this base measurement because we don't know if that measurement is being cut exactly in half. Okay, so we want to, from our 55-degree angle, we know that the h is the opposite. We're given the hypotenuse, which is across from the 90-degree angle in this smaller triangle on the right-hand side. So in order to find our height, we're going to use the sine function. So the sine of 55 degrees equals opposite h over hypotenuse 29. And we can put that over 1 to finish up our problem. So when we cross multiply, what we see is the fact that h equals the hypotenuse value 29 times the sine of 55 degrees. Okay, and we're going to use this idea because this height measurement always will work when we're dealing with a side angle side situation. So on our calculator, if we find the sine of 55 degrees, we get 0.8192 times 29. Okay, we get a rounded to 1 decimal place value of 23.8. And then we can multiply that all out to get our area. 23.8 times 33 divided by 2, and we get an area of, rounded to 1 decimal place, 392.0. We've got a 9 that's being rounded up from there. Area measurement is centimeters squared. So now, let's come up with a generic situation for any triangle. Okay, it would also work with this triangle above. Okay, we've got the 38.5. That's actually the base of this triangle because the height is being drawn from that. Okay, so you always want to be careful of base versus height. The 21 isn't necessarily the base in this situation. We always want to look at the right angle, and that defines our base and height for us. So this is the base. This is the hypotenuse that we're going to use to find the height measurement here. And you can see it always works the same way. Sine of 72 equals our h, the opposite side, over the hypotenuse side. So now, for any triangle, okay, any acute triangle, okay, we want to work with this situation. If we have the two sides and the included angle, and that's the important part, our area formula is 1/2 side A times side B times the sine of C. Okay, now know that these lengths and names can change. Okay, what's the important part here is your two side lengths that you're given have to come together and make the angle that you're given. Okay, and if you have those three pieces, given side, included angle, then you can use this area formula to find the area of that triangle. Okay, now we're going to use this idea to develop the law of sines. So now, quick situation test here on your right triangle trig. If I want to find the sine of B, okay, notice I can't use the full triangle. I have to use my right triangle to find the sine of B. So the sine of B, opposite over hypotenuse. So for the sine of B, H is the opposite, A is the hypotenuse, and we get this function here. Okay, now if I want to find the sine of A, okay, sine of A, once again, we have to use only the right triangle to find the sine of A. So once again, H is the opposite and B is the hypotenuse. Okay, so I use my SOHCAHTOA and I find that value. Okay, notice, okay, there's one similarity in these two formulas. Okay, they both use that height value H. It's not a hypotenuse, but it is a height value of H. So now, since both of these formulas can use the height value, okay, I'm going to solve them for H. So on this side, I have H equals sine of B times A. And on this side, I have H equals sine of A times B. So now I can set these two height measurements equal to each other because they're both equal to H. Sine of B times A equals sine of A times B. And if you think back to almost everything we've done in this semester, we've always dealt with proportions. Okay, now, this isn't a proportion, but it's something that's already been cross-multiplied for us. So what we want to think about is, what would we have cross-multiplied to get this answer? Okay, and the answer is, we would have had sine of B over B equals sine of A over A. Now, if you cross multiply this function, you'll see that you get our answer that we have here. And what we've done here is we have created the law of sines. Okay, the law of sines states that for any acute triangle, okay, we want to be careful with, you know, what we're dealing with here. For any triangle with angles A, B, and C, side lengths A, B, and C, okay, we can set up the ratio. Okay, the sine of angle A across from side A sets up our first ratio. The sine of angle B and then side B. Okay, notice we have to go across the triangle to be able to find those pairs. And what we can do is we can set up all of these pairs, angle C across from side C. Okay, and all of these proportions are equal to each other because all of these proportions work into that height value in the middle of the triangle. Okay, so now let's use this process to find a missing value. Okay, one thing I always want you to do when you're finding these values is make sure that you identify your pairs. Okay, and remember, your pairs have to be the side that's across from the given angle. Now, one thing you want to be careful of is sometimes we could give you a situation like Z, and then you would say, oh, Z doesn't have an angle that's across from it. That's when you have to use your geometry knowledge and say, well, I can find angle Z. So if I can find that angle, you can still use the law of sines. Okay, so now for my green pair, I have the sine of 79 degrees over W. And that's going to equal my blue pair, the sine of 52 degrees over 28. And then from here, it becomes a cross multiply and solve. Now, remember, if you can do these problems with the sine values, that's the best. Okay, worst case scenario, convert them to a 4 decimal place answer, and you can use those 4 decimal place value and get a very close approximation of the correct answer. So now we cross multiply W times sine of 52 equals 28 times sine of 79. Okay, to get W by itself, we're going to divide by the sine of 52, divide by the sine of 52, and we will get our answer for W. Okay, so we've got 28 times the sine of 79. And then we divide by the sine of 52. And we get 34.9 for the answer. Okay, now remember, one thing that you can do in this process, you can turn your trig values into actual numerical answers. Sine of 79.9816, sine of 52, 0.7880. Okay, so you can work this problem the same way. 0.9816 times 28, enter, divided by 0.7880. Okay, your answer is slightly different, but in this case it rounds to the same answer. Okay, and there's just a few situations where your rounding would be off by 1/10 decimal-wise, just based on how the numbers rounded. Okay, so let's look at one more situation where now we're given the information, but we're wanting to find the angle measure. Okay, so we're wanting to find the angle measure. Once again, we're pairing up the values that are across from each other. So I've got B and the 150. So that one is going to be the sine of B over 150 equals, and then I have my second pair, the 68 degrees and the side opposite, the 250. Okay, so I have the sine of 68 over 250. And then, like almost everything we've done in this semester, our first step to solve this is to cross multiply and solve. Okay, so we have the sine of B times 250 equals 150 times the sine of 68. Okay, then we divide both sides by 250. Okay, and we get a numerical value that's going to equal the sine of B. Okay, so we have to turn this into a numerical answer. Sine of 68, enter, times 150, enter, divided by 250, enter. and we get 0.5563. Okay, notice we're going to 4 decimal places here. This really gives us some really good accuracy, so we don't have to worry about the fact that we're using a rounded value for this calculation. Now, to get the angle B by itself, remember before we talked about mentally we want to think about the fact that we're dividing by sine to get B by itself. Okay, the calculator does not have a button for dividing by sine. So what we're going to do is we're going to use the sine -1 because that's really what it means if sine is in the denominator. It has a -1 exponent. And then we just plug our decimal value into that. So we've got second sine gives us sine -1 or inverse sine of 0.5563. And we get an angle measure for B of 33.8. Okay, now remember, some of these problems can mix you up a little bit. They can ask for a side that does not have a matching angle pair. So in the end, if you're asked for this upper angle, you would still solve the problem exactly the way that we did it. You would solve for B first, and then you would use the fact of the 3 angles of a triangle add up to 180. Okay, and that concludes our lesson for today, working with the law of sines to solve for missing angles and missing side lengths. Thank you, and have a good day.